Hello everyone and welcome back to our Python programming series. This is our 8th lecture. In the previous lecture, we learned about nested loops and pattern printing. We learned how to put one loop inside another and how to use nested loops to create different patterns. Today, we are moving on to another very important topic in Python, collections and data structures. We're going to learn about 4 important Python data structures, which are lists, tuples, sets, and dictionaries. All 4 allow us to store different pieces of data, but they work differently and are useful in different situations. We'll start with lists, then move to tuples, sets, and dictionaries. At the end, we'll compare all 4 so that you can know when to use each one. Okay? By the end of this lecture, you should be able to understand what Python collections are and why we need them. We'll learn how to create lists, access their elements, modify them, and use common list methods. Then we'll learn about tuples and one of their most important properties, which is immutability. After that, we'll learn about sets, which are particularly useful when we want to work with unique values. Finally, we'll learn about dictionaries, which store information in the form of key-value pairs. We'll also compare these 4 data structures and look at their main differences. First of all, the question is, why do we need collections at all? Let's start with a simple problem. Suppose we want to store the marks of 5 students in a class, right? We could create 5 separate variables like this. For example, here we made mark 1 is equal to 85. You know what? I'll just show it to you on our code editor itself, right? So, if we want to store the marks of 5 students, the first way that comes to our mind right now is to create 5 different variables. Mark 1 is equal to, let's say, 5. Mark 2, 66. Mark 3, 78. Mark 4, 99. And Mark 5, 54. Okay, so this is the first method that would come to our mind, right? We can create 5 separate variables, each storing the mark of one student, right? This works in this particular case, right? When we have to store the marks of 5 students, we can do this. We can create a separate variable for the marks of each student. But what if we have to store the marks of 500 students? What if we have to store the marks of 1,000 students? Okay, 1,000 might be too much, but what if we have to store the marks of 100 or 500 students? Doesn't this look a little tedious, creating a new variable for each and every student? Hmm? Also, it will take as much space in the memory, right? Each variable here is a separate memory location. That is why the space it will take up in the memory will be more, right? Can we, even without the memory problem, can we create 100 different variables? It's very difficult, right? That is why instead, what can we do? We can put all the marks together into a single collection. That way it will be stored, that way it will actually take less memory, right? But it will be stored inside a single variable instead of these multiple variables, making like 100 variables that you can't remember, right? It will make our data so much easier to manage. What we can do is marks is equal to square brackets 85 90, no, it's 66, 78, 99, 54, and square bracket close, right? Do you think this looks better or this looks better? This looks much easier, right? We didn't have to create a new variable each time. We can access individual values from this, add or remove values, and use loops to process all of them. See, this is why we need collections. If I put this inside comments, and if I print marks here, I'm getting all of these values just using one variable, putting this one variable here. See? And if I try to use this with a loops, oh, I accidentally removed this whole thing. See? The for loop can run through this so easily, because do you remember the for loop runs through collections of data, right? We were previously, when we learned about for loop, we used it with range function because it needs a range of values, and this collection is providing it with that, so we can easily use it here instead of using range function. So yeah, let's move on to lists. It is the first data structure that we're going to learn today. A list is a ordered collection of items. We create a list using square brackets. What we created here was a list, okay? It is created using square brackets. For example, this list here. Let's code this once. Let's name our list fruits. Lists are enclosed inside square brackets. Now we can use any data type. For example, we used int in the earlier one. Now we are using strings inside it. There are some restrictions. I'll explain it to you. Mango. Here, fruits is the name of our list. The list contains 3 strings, and as you saw before, the list can also contain numbers. Square brackets. 4, 59, 67. Let's keep it 3 as well, See, it can store strings, it can store numbers, it can even contain different data types inside the same links. For example, square brackets, Python 10 3.14 true. As you can see here, we are enclosing inside the list a string, an integer, a float value, as well as a boolean value. It can store all of these, and yes, it is correct, it will print all of these. Let me print these ones and show it to you. See, all of the values are being printed. We can store any data type inside it, okay? But although this type of mixed data type lists are possible, when we are working with real programs, we usually store related types of data together because it just makes solving the problem easier, right? So, important characteristics of lists. Lists are ordered, right? Which means each item has a defined specific position, okay? Each item has a specific position inside the list. They are changeable, which means we can modify them. They are mutable. You can also say mutable. This is the term used to tell that we can change them, okay? And they also allow duplicate values. I mean, if I write Python again here, then again write Python. There are 3 duplicate values, right? Does it allow it? Let's run it and try once. See, lists can include duplicate values as well. So lists are ordered. Every element has a specific position in the list. Lists are mutable, changeable. It can be modified, and they also allow duplicate values. Okay, they don't automatically remove duplicates. Now, assessing list items. Since lists are ordered and each element has a specific position, we can use these positions to perform a variety of functions. Okay, uh, the position that every element occupies is known as its index. We learned about indexes earlier, right? And as you know, Python uses zero-based indexing. That means that the first element of the index is 0 and not 1. Okay. For example, here, apple, banana, mango. The index of this apple is not 1. This is not 1, 2, 3. That is incorrect in Python. The index of apple is 0, the index of banana is 1, and the index of mango is 2. So the indexes go from 0 to 2 actually. Okay, and if we want to print only apple from this fruits here, you can write print fruits square brackets 0. This 0 inside the square bracket is used to refer to the index of this variable fruits. Okay, just like this we can also print the other elements inside it using the correct index and print fruit 2. Let's try to run this. Oh, see, these mistakes can be made. The variable name here is fruits, but I have written fruit here. So I'll just change that and try to run it again. See, apple, banana, mango. This is our full list of fruit printed here. Then a full list of numbers, full list of data, and then apple, banana, and mango printed individually using these 3. Okay. We can also use negative indexing, which starts from the back. It doesn't start from 0 then it starts from -1. The last element of a list is -1 index. then -2, -3, like that. So if we start from here, then it's 0, 1, 2, and if we start from here, then it's -1, -2, -3, and so on. Okay, here it will be -1, -2, -3, -4, -5, -6, and if we look from the beginning, then it's 1, 2, 3, 4, 5, 6. Okay, let's print something with negative indexing as well. Let's print this data list with negative indexing one by one. Data square bracket -1, print data square bracket again -2, print data square bracket -3, print data square bracket -4, print data square bracket -5. How many are there? -1, -2, -3, -4, -5, -6. Okay, one more. Print data square bracket -6. Okay, shall we run this once? Let's read this and run. See, these are our full lists printed. Then apple, mango, and banana printed using these positive indexing, and then from here Python, true 3.14, true 3.14, 10 Python, 10 Python, printed using negative indexing. Okay. Of course, there are easier ways to print the whole list also. We'll look at that in a bit. It's basically the same thing here given here. Lists use indexing, and they have this list of fruits here. Positive indexing 0, 1, 2, accessing elements, we just learned that. Output will be the output of fruits square bracket 0 and fruits square bracket 1 will be apple and banana, and then -1 will be mango because -1 is the last element of the list always. So now modifying lists. One of the most important characteristics of a list is that it is mutable, changeable. We can modify it. Mutable basically means that we can change its contents after creating it. It isn't fixed. For example, I go here, I'll just delete this. Wait a second. Okay. If we write an example, let's take fruits again. Fruits is equal to fruits is equal to apple, banana. Oh, look, I've made a mistake with the brackets here. Apple, outside of brackets, comma, banana, outside bracket, comma, mango. And how can we modify? We want to put orange instead of this apple. We want the list to be orange, banana, and mango. What can we do in this case? We'll just access the index of apple, right? We'll access the index of apple and change the value inside it. How will we do that? We'll write fruits 1 is equal to orange. Okay, just this. Oh wait, we have to change apple, so it will be 0 because lists start from 0, 0, 1, 2. So if we put 1 here, then it will change banana to orange. We want to change apple to orange. And yes, just this modifies our list. Now if we print our list, how can we print the full list? We just have to write the variable name as we were doing for any other variable. If we don't want to access a single element and we want to print the full list, we can just write the variable name and it will print the full list. So we write fruits here, and if we run this, see, orange, banana and mango, not apple, banana and mango, orange, banana and mango. We can also change anything else if we want to. If we want to change banana to, let's say, peach. Okay, if we print it now, print fruits, wow, 0. See, banana to peach. If we run this now, it has been modified even further. If we run this before modification, see, this is our original list. This is after modifying apple to orange, then after modifying banana to peach. See, this is how you can do it. And the list itself hasn't been replaced. We simply changed one of its elements. Can also do another example with numbers this time. Write numbers is equal to 10, 20, 30. Numbers, if we want to change 10 with 100, we'll just write numbers 0 index because 10 is at the 0 index position. Like this, there can be a thought process to it. First we'll look at what we want to change, like the position of what we want to change. We want to change 10 to 100. What is the position, what is the index of 10? It's 0. So we'll write variable name square bracket 0 to access this 10, and then equal to assign a new value, and we'll assign the value 100 to it, and then we'll write print numbers. And if we run this now, see, 10 has been replaced with 100. This is something we can do with lists because lists are mutable. Now let's look at how we can add elements to a list. Of course, since we can modify a list, we can add or subtract elements from it, right? So one commonly used method is to append. Append adds an element to the end of the list, right? Let's try using append first. We'll remove this and this. Fruits is equal to apple, banana. Okay. Now I want to add mango to this. Okay, I want to add a new item, a new element to this list, which is mango. What do? We write variable name, which is fruits here, variable name dot append, variable name that which is fruits here dot append, then parenthesis are normal brackets, and since we are using string here, we have to write it inside quotation marks, and we write mango here. Okay, variable name dot append parenthesis and whatever we want to append, and it has been done. This is it. Simple, right? If we print fruits now, and if we print fruits before appending, let's run this. See, before appending it was just apple and banana, then we appended it here, and now the list has become apple, banana and mango. And our second method is to use insert. Unlike append, insert allows us to specify where we want to add the element. When we used append, our element mango was inserted at the end of the list by itself automatically, right? That is append. But using insert, we can specify where exactly we want to position the new element. For example, we go here, if we write, okay, the syntax is variable name dot insert. It's the same as append, but just write insert instead of append here, and again parenthesis. Now what we'll do, we'll specify the index number of where we want to insert it. For example, this is index 0 and this is index 1. I want this position to now belong to orange. Banana will automatically be shifted. So I'll write insert 1, index of position I want to add it to, and then what we want to insert into the list, orange. And we print fruits again, run this. See, in place of banana, which was first at the first index, right? It was as the first index, right? 0, 1. Banana was at the first index, but now we have changed that to orange. What if we change it to see the first? No, wait. 0. We want it to be the 0th index. See, in place of apple, which was the 0th index before, orange has been inserted. Similarly, we can change it to the second index. It's not present here, but it will be added at the end with this. Okay, so this can be done. You can also actually show append alongside it just to compare. Let's keep it as 1 only, and we'll write fruits dot, what do we write, append, and we don't have to specify position here, we can't do that, but we can in insert. So append orange, and well, let's append something else, append mango, and print fruits. Okay, take a look at it once. Shall we run it and see our result? See, this is our original list, apple, banana. Okay, Then we inserted orange at the first index position. So it became apple, orange, banana. And then we wanted to append mango. After appending, it will be ended at the last. So the list became apple, orange, banana, and mango. Okay. Insert will put it at the specified index and append will put it at the end. So we learned how to add elements to the list. But of course, if we can add elements, we can also remove elements from the list. The first method is to use remove. If we go here now, after we did all of this, and we write, the syntax is similar, variable name dot remove this time, and what we want to remove will write here. I appended mango here, but I want to remove it now. I'll write mango, okay, and run this. So I did print it. I have to print it to show to you guys. Yeah. See, original list. We inserted orange. We appended mango. We wanted to remove the mango, so we just used remove here, and our mango is gone now. Okay. Now let's take a look at the other examples. We have pop. Pop removes the elements at the specified index, just like we could use insert to insert an element at a specified index. We can use pop to remove the elements at the specified index. So if I go here and I do fruits, again the syntax is similar. I do fruits dot pop. Let's do 2. We want to remove banana, and then we'll print the list. Shall we run this? Let's delete this once. Yeah, let's run it. As you can see, banana has been removed from the second position using pop. If you think that it might be because it is the last position, let's do 1 this time. And run it. So what was at the first position? 0, 1. Orange was there. Pop removed this orange, and we were left with apple and banana once more. Okay, that is basically our pop function. And then there is the del statement. This also deletes the element at index 0. I mean, we can use any index, but if we write it, we write del, here we write del first, del fruits, and then we write our index 1. We'll put this inside hashtag. We commented this, so now our orange is technically not removed, and we use del fruits 1 in this place and run it. I didn't print it. Okay. Yeah, let's run it now. As you can see, using del as well, we can remove elements from a specific index. Orange has removed this time as well. It was removed when we were using pop. Okay. Of course, if we want to, we can also delete elements from the original list. I think I just I only remove the elements from the added ones. I'll just remove here, I'll remove banana. No, let's remove apple. Apple has stayed safe for so long, right? Okay. See? Apple, banana, original. We added orange using insert at first position. Then we appended mango. Then we removed mango using this one. Then we used pop 0 to remove apple from the 0th index, so it became orange banana. And then we used fruit, this del one. See, del is not using this syntax that every other function is using here. It's not fruit, it's not variable name dot del, it's del variable name, then square brackets and index number. Okay, and using that we removed banana and we were left with just orange in our list. Okay, let us now look at useful list operations. Python provides several useful functions and methods for working with lists. The first function being len. Len tells us how many elements are present, right? Let's do it once. If we have a list numbers 10, 20, 30, 40, and we want to print the length of this list, we'll just write len brackets variable name of the list. Okay, print len bracket numbers, and if we run this, we are getting 4. That means the length of our list here is 4, and indeed it is. 1, 2, 3, 4. Index and length are different. Index is counted from 0, but length is counted from 1. Okay, so the length is 4, but the index is 0, 1, 2, and 3. The length 1, 2, 3, 4. Okay, don't get confused in this. Now the next one is checking if an item exists. We can use in for that. For example, here if we do print 20 in numbers. So what this is basically doing is, this is checking if 20 is inside this variable numbers here. Is it inside this? Yes. So what will our answer be? If 20 is indeed in this variable, what will our answer be? Shall we look at it? True. First we printed the length and then it is printing true because 20 is in numbers. Okay, it's giving a boolean result. What if we checked for something that is not here? What if we write print 100 in numbers? This is basically asking, is 100 present in this list called numbers? Let's run this, and we are getting false this time. We were getting true for 20 because 20 was here. We're getting false for 100 because 100 is not present in this list. Okay, we can use this to check if an item exists in a list. Then we can use sort to obviously sort a list. If we have this, we have these numbers, right? Let's jumble this once. 66. Yeah, that should be enough. Now if we use sort, we'll write variable name numbers dot sort parenthesis, just that. Okay, that is all we need. We'll run this. We didn't print it. Okay, let's also print the original list as well. And we'll run this. See, first our original list 60 20 6 4, and then after we've used numbers.sort and printed it, we're getting a sorted list. It has been arranged into an ascending order 6 20 40 60. This was all jumbled, right? So that is how we can sort it. And numbers.reverse, to reverse the list, if we use it here, numbers dot reverse variable name dot reverse. Okay, and we have to print it once. Print numbers. Yeah, if we run it, see, so numbers dot reverse didn't sort our list, it just reversed the order of the list. First our list was 60 20 6 40. After reversing it became 46 20 60, and then sort changed it from smallest number to largest number. Okay, and then we have, yes, of course we can use looping with lists, right? We can, for example, here for loop is being used. If we go back to our example and we write for number in numbers colon print number, right? Let's open on, yeah, let's run this. As you can see, this was our sorted list, and using for loop we looped through each element of the sorted list and printed it 6 20 40 60. Okay, and as you can see, sort changed the list itself, right? Because when we looped using for loop into the list, the answer came out in sorted form, right? So yeah, next is some practice with lists. Because this is a new topic, we'll combine what we have learned about lists, right? We have actually done all of these already, but I suppose it will be a good revision, so let's do it again, right? Let's practice once, because this might look confusing at first. Suppose we have a list, let's take numbers again, is equal to 10 20 30 40 50. Okay, first we print it, print numbers. Okay, print list, print its length, add new number, remove new number. Okay, printed list, done. Success. Then print the length of the list. Done. Then add a number. We can use any of the methods I just taught to add. Let's write numbers dot append. Let's use the append here. We can also use insert if we want to. Print numbers again to see the change. See, 60 has been added. Then we can remove an element using any of the methods we learned. Let's just use normal remove method. Remove 30. Print numbers again to check. See, 30 has been removed. And what was the last one? Print each number using a loop. We can use a for loop to print each number. For number, we can use any variable here. I have been using number. We can also use num, x, y, z, any variable. Num in numbers. Print num. As you can see, it has looped through each element and printed it one by one. This example combined several concepts that we've learned. The important thing isn't memorizing every method, it's understanding what each method does, okay, and knowing where and how we can combine these operations to work with our data. Let's now move on to a new topic. Let's move on to our second data structure, which is known as a tuple. A tuple is an ordered collection of items. The main difference in syntax is that we normally create tuples using parentheses. We don't use square brackets, we use normal parentheses. They are similar to lists in several ways because they are ordered. Lists are also ordered. They also support indexing just like lists. They allow duplicate values. They can be looped through. But there is one very important difference. What is that difference? That is, tuples are immutable. Once we create an tuple, we cannot change its elements. We could modify our lists. Lists are mutable, changeable. We can modify the list. But tuple is immutable. We cannot change its elements after we create the tuple, okay? This is very important to remember, okay? Let's understand immutability with an example, okay? Let's first create a tuple. Colors is equal to normal parenthesis, no square brackets, no curly braces, nothing, normal parenthesis, okay? Red, green, blue. Now if we try to change any element from it, if we try to modify it and replace the zeroth element, the element at zeroth index, with something else, yellow. We could do this in lists, right? If this was a list, then this red would have been changed with yellow. But can we do that here? Let's run it and see. We are getting an error. Oh wait, it's the wrong type of error. Yeah, we are getting an error because tuple object does not support item assignment. See, if this was instead a list here, if we put it inside square brackets instead, I didn't print it. See, if we used a list here instead of tuple, right, our red was successfully changed to yellow, replaced with yellow. Here it was red, now it's yellow. But if this is a tuple, let's also print the original one once. Okay. Yeah, red was changed to yellow in a list, but if this is a tuple, which is just replace the square brackets with normal parenthesis. Now this is a tuple, and as you can see, our tuple has been printed before trying to modify it, and after we tried this, we're getting an error because you can't do this with tuples. Okay, so then why should we use tuples? If we can't modify data in tuples, why should we use it? Well, since we can't modify the data, tuples are useful when we have data that shouldn't be changed accidentally, right? For example, there are certain parts in our program that we don't want to randomly accidentally change, right? Then we can use tuples. But even though tuples cannot be modified, we can still perform several operations on them. Okay? We can access elements, we can find their length, we can check for membership using the in function, right? And we can loop through them just like we loop through lists. So it being immutable doesn't mean it's completely useless or something, right? Let's try these functions on tuples. Let's make our tuple colors again because I accidentally deleted that as well. Red, green, blue. Print once just for it to be a check case or whatever. See, it has been printed properly. Now we can access the elements. We can write, we use colors 0. This will access the red element. And we can print this. Print colors 0. See, even though we can't modify the elements, we can access them. If I write 1 here, let's access all of them actually. Print colors square bracket 1, print colors square bracket 2. Yeah, see, we can access all the elements, we just can't change them. We can also find the length of the tuple using again our len function. Len, then variable name which is colors. See, the length is 3 because 1, 2, 3. Again, length starts from 1, but indexing starts from 0. Don't confuse them. And we can check for membership. We can check if this has the color blue. So check blue in colors. What will we get from this in function? Membership function will get true because blue is indeed in this tuple. and if we access something that is not there, lavender for example, it's returning false because it's not there in this. And if, if we try to loop through it, we can loop through it using for loop, because this is also a collection of elements. We can use for loop here. For color in colors, print color. This will go through our tuple one by one and print the elements. See, red, green, blue. Okay, so we can use all the operations, but except the ones that change the elements. Okay, now we move on to our third data structure, which is sets. A set is a collection of unique values. Pay attention to the unique. Okay, it doesn't keep duplicate values because it only is keeps unique values. It is a collection of unique values. And a set is enclosed inside curly braces, right? They are also unordered. We can't we shouldn't allow on positions or indexing in it because they are unordered. Lists were ordered, each element has a specific position. Tuples were ordered, each element had a specific index. But for sets, they are unordered. Their positions can change. If I have printed an element, for example, I've print 0 index, right? If I print it again, the same 0 index, the two answers can be different actually. Okay, so that's that, and they are changeable. Changeable means mutable. Okay, unlike lists, sets are mutable. Let's look at it here. Let's create a set. Since we have been using numbers, let's use number here as well. And numbers is equal to 1, 2, 3, 4. So curly braces and then our elements of the set. Okay, if we want to print our set, we can just use print variable name, and it has been printed. Okay, and then if we add duplicates here, what happens? Like I told you, sets store only unique values. They are a collection of unique values. What if we store duplicates here? 1, 1, 2, 2, 2, 3, 3, 3, 3, 4, 4. What now? We said that sets only store unique values, but what if we ourselves give it duplicate values? What will happen? It is still printing 1, 2, 3, 4. What is happening is, even if we give it duplicate values, it will just automatically remove those duplicate values and only keep the original values. Okay, the duplicates are removed. And if I told you about the indexing and all, if we print numbers 1, oh, wrong variable name, sorry. If we print numbers 1, see, you can't use this here because it just isn't supported because it is unordered. Okay, but then why do we use sets? You can think of sets as being useful when the main thing we care about is which unique values exist, okay, rather than the positioning. When we are just worried about there being unique values and we don't need to care about the positioning, indexing, whatever, then we can use sets. And yeah, of course, sets also have their operations. They become particularly useful when we want to perform mathematical set operations, right? We have used sets in mathematics, right? So let's delete this first. If we do numbers dot add 5, using this we can add elements to a set. Numbers dot add 5 and print numbers. See, 5 has been added to our set, and as you can see the duplicate values are being ignored, removed. We can add and we can remove using remove. So it's numbers dot remove and then the element to be removed. Let's remove 3 from here. Okay, and print numbers again. See, 3 has been removed from here and 5 has been added right here. So yeah, we can also combine sets using operations such as union and intersection, just like we used in mathematics. Union contains everything from both sets and intersection contains only the values which are common in each set. Uh, let's create a new set. Let's name it set A, and we'll put 2, 4, 5, 6 values here, and set B will put 6, 7, 8, 9, 10. Let's also put 12 and let's put 12 here as well. There's no particular reason, just like this. Yeah, so we can use union, which will contain everything from both sets. Okay, if we write set A dot union set B, forgot to print it again. This has become a running theme in our lecture today, I guess. Me forgetting to print it. Yeah, as you can see, set A, set B. Let's also print set A and set B separately first. Print set A, print set B. Yeah. As you can see, this our set A has been printed, our set B has been printed, and we used set A dot union bracket set B to join set A and set B together. Give us all the elements in both the sets. So it's 2, 4, 5, 6, right? And it has also become in ascending order. 7, 8, 9, 10, 11. 7, 8, 9, 10, 12. Why did it not repeat 6? Because it was already present in both the sets, so there is no need to repeat it. Union basically gives us just all the elements of these two sets. And we can also use intersection to only get the values that are in common, that both sets have in common. So we'll write, let's not forget print this time. Print set A dot intersection set B. Okay, and if we run it, see which values are present in both set A and set B. 6, 6, and then anything else, 12, 12. So we get 12, 6 here when we used intersection on this. Okay, union means everything together, intersection means what they have in common, right? Hmm. Let us now move on to our fourth and final data structure for today, which are dictionaries. A dictionary stores information as key value pairs. Think about a real dictionary. You have a word and you have its meaning, right? Word meaning, key value pairs. Key, which is the word, and its meaning will be the value. That is how it is in Python as well. We have a key and a value associated with that key. For example, we'll just remove this. Yeah, let's make a dictionary. It's also enclosed in curly brackets, right? Enclosed in curly brackets. We'll write our variable name student. If we want to store the information about the student here, right? So curly braces, name Aman. This name here is our key, okay, and the one on the right side is the value for that key. Key value, this is a pair, key value pair. Okay, let's also write age 16 and then marks. Forgot to add comma here. You have to put comma between different key value pairs. You don't have to put it after every key and value because this is a pair. So key colon value comma. And also you have to obviously take care of the data types. Since we have used string here, we have put it inside put it inside quotation marks, right? So key value pair comma, key value pair comma, and we reach here marks 85. Okay, and if we print student, see, this is our dictionary here. The name is here name, age and marks are keys, and Aman 16 and 85 are values. The key is used to identify or access the value. Okay, and for example, if we want to access the name of the student, we'll write student square brackets the key. We don't have to write the value, we'll just write the key, and we run this. Aman. So instead of using indexes like we did with lists, we are just using the key to access the value here. We were using indexes there and we are using keys here. If I want to access the age, name of dictionary, square brackets, key, and I can also similarly name of dictionary, square brackets, key, let's access marks here, and see, Aman 1685. It has been accessed. Okay, so not difficult at all. Hmm. So now we move on to our next topic, which is assessing and modifying dictionaries. Let's see how we can work with dictionary data. First, we can access a value using its key. If we want to add a new key value pair, we can simply assign a value to a new key. Let's look at it. If we, as you can see, we accessed it already here, right? These three we accessed. If we want to change or add a new key value pair, we can just write student. Let's add course. This is our new key. This course is our new key. We were accessing keys using this, right? So yeah, this is our new key, and course is equal to Python. Okay, so now this new key value pair has been added. Now if we print our dictionary, see, this wasn't there earlier. This has been added using this very easily, and we can also modify an existing value, of course. For example, if we want to change the marks, if we accidentally entered the incorrect marks earlier and we want to change it, we'll write marks, access the key using this, and then change the value to 90. And we can also remove a key value where using pop. If we want to remove, for example, age from here, we'll just write student dot pop and key name, which is age here. And if we print our dictionary again, print student, see here marks have been changed using this thing to 90, and we used pop to remove age. Okay, and of course we can also loop through dictionaries, right? We can loop through the keys, and we can loop through the keys and values if we want. For example, for key in student, this will loop through simply the keys. What are the keys here? Name, removed age, so marks, course. Okay, so we can do that. See, it only printed the keys and not the values, name, marks, course. If we want to loop through keys and values, we can just add another variable here. We'll add key comma value, and then in print as well we'll add key comma value. Here Python gives us both the key and the corresponding value during each iteration. Okay, we run this. Okay. We'll also have to modify something here. Yeah. So we do key comma value in student dot items bracket and then print key comma value. Okay. We can also, if we use student dot keys, it will basically outside this loop. This is a different thing. If we write student dot keys, it will give us all the keys. Forgot to print it again. See, we got all the keys. Okay, and if we want, similarly we want only all the values, then we can write student dot values, and if we want the key value pairs, can print student dot items. Okay, items, the same that we used here for key value pair in student dot items. Okay, and we'll run this. See, keys values items, that is key value pairs. So that's about it for the dictionaries. Now if we compare the four data structures, this is important because the goal isn't to memorize the four different syntaxes. The goal is to understand which one to choose for a particular problem. You can use a list when you want an ordered changeable collection and duplicates are allowed. You can use a tuple when you want an ordered collection that shouldn't be changed. You can use a set when you mainly care about unique values. You can use a dictionary when you want to associate keys with values. Okay, so list collection, tuple fixed collection, set unique collection, and dictionary labeled information. So here are some practice questions for you to try. If I look at these, we have actually done all of these in this lecture, if you remember, right? If you can't understand any of these, you can go back to the corresponding parts of the lectures to check, right? We have done sets intersection using, yeah, we have done all of these practice questions in the lecture already, but you can practice this yourself once to consolidate your understanding just. And let's summarize today's lecture. We started with lists. Lists are ordered, mutable, and allow duplicates. And we learned about tuples. Tuples are also ordered and allow duplicates, but they're immutable. Then we learned about sets. Sets store unique values and don't use normal indexing. Finally, we learned about dictionaries. Dictionaries store data as key value pairs and allow us to access values using keys. The important thing isn't just memorizing the syntax. When you're giving a problem, think about what kind of data you're dealing with. Do you need an ordered correction that you can change? Then you will use a list. Do you want data that shouldn't change? Then you can use a tuple. Do you want unique values? Then maybe you can use a set. And do you want to associate labels with values? Then you can use dictionaries. So yeah, that is it for our lecture today. And in the next lecture, we learn about functions in Python. Thank you.